Okay, so now we have a similar setup, except now we have two green spring scales on the left and a brown one on the right. And so what we're going to do is get Nick to tell us the tensions on both of the green spring scales, and we'll calculate the one that should be on the right. So Nick, can you please read off the two green spring scales for us?
2.5 and 3.2.
Thank you, sir, and hold what you got and don't let anything change. Okay, so for this problem we had three horizontal forces. We had a T1 to the right, we had a T2 to the left, and we had a T3 to the left. And of course we still do have a weight and we still do have a normal force. We're not going to worry too much about those for this problem. What we are going to do is, since Nick told us the value of both T2 and T3, we're going to see if we can figure out the value of T1. So, once again, since we're in equilibrium, the net forces in the y direction still have to equal 0, so of course N still has to equal mg. We're not worried about those for right now, though. What we do care about is that net force X also has to equal 0, and that means that the sum of our forces to the right, which would just be T1, has to equal the sum of our forces to the left, which would be T2 plus T3. So we should see then that T1 is going to equal 2.5 plus 3.2, which would give us 5.7 newtons. And so, in our next video, Nick's going to read off the value for T1, and hopefully it'll be about 5.7 newtons. It won't surprise me if it's a little bit off, because it counts on him holding the correct tension in that one spring scale to the left. But let's see what he gets. Okay, so now that we've calculated the tension that should be on the brown spring scale, Nick, can you tell us what you see there?
About 5.1.
Thank you, sir. Alright, so what we see there is that Nick read off a tension of 5.1 newtons to the right, and we had calculated 5.7. But you'll also notice as he leaned over to read the scale, if he didn't keep his hand perfectly still and keep the exact same tension in there, that would have changed. So it's not surprising that it's not perfect. It still came out pretty close, and this is government work, so we'll take it.